Hi, everyone. Thanks for the introduction. I'm Ellen Bruno. I'm Cooperative Extension Specialist at UC Berkeley in the Ag and Resource Economics Department. Thank you so much for the opportunity to come and speak today. I'm actually a part of the other NEFA grant on groundwater that was awarded in the same year with a bunch of research in the Southwest, and so it's cool opportunity to be here to interface with you all and catch up with folks and learn a little bit more about your guys' project. But so this presentation is going to draw on work that's funded by the other NEFA project, much of it joint with Andrew Ayers, who's at University of Nevada, Reno. And so I'm going to be talking a bit about groundwater markets, their status in California under SGMA, and then do kind of a deep dive of one groundwater market in Southern California that's based in an adjudicated basin in San Bernardino County, where there's been trading over the past 25 years to see what kind of lessons we can learn from that as groundwater markets develop under SGMA in the rest of the state. So I know we already got a lot of background today on SGMA, particularly in Paul's talk this morning, but it's the reason that I'm talking about groundwater markets today. It's what has kind of driven any kind of incentive to develop groundwater markets in California. So I won't spend much time talking about SGMA. The only thing I wanted to emphasize was that this kind of aspect of local control under SGMA, in that it gives local agencies both the flexibility and the authority to do things that they weren't previously had the authority or incentive to do, including groundwater trading. Because, right, if there's no scarcity on groundwater, there's no limit on groundwater, there's no incentive to trade it, right? And that's really what SGMA offered here, as well as the framework for local agencies to develop those markets. So other things as well that were covered in Letitia's talk too, and talking about impacts of SGMA, but I have some of the statistics from PPIC reports. Across the state on average, PPIC estimates about a 16% cutback of water use in the San Joaquin Valley, and that level of groundwater cutback could have pretty significant impacts for fallowing and crop revenue losses as a result. But trading, if like local groundwater trading was allowed within that, then that could actually reduce some of those costs of SGMA on an order of 33 to 50%. So a very meaningful cutback in the potential economic losses of SGMA. And therefore a tool that we should really take seriously going forward as a potential policy instrument for achieving some of these SGMA guidelines. Okay, so several unanswered questions that I'm going to try to address somewhat in this talk. Sort of what is the potential for groundwater trading? What role are water markets playing under SGMA so far? What kind of challenges exist with implementation, and what can we learn from past trading in Mojave's adjudicated basin? These are questions in general that I'm interested in and working on as part of my research agenda, and just kind of try to touch on some of these in my talk and hopefully discuss with you all further afterwards. So, but to back up, make sure we're all on the same page, I wanted to start off by defining what a groundwater market is. For a groundwater market, I'm talking about the voluntary but compensated transfer of allocations to pump groundwater, as well as the rules and institutions that govern trading. So it's often, we're more acquainted with surface water transfers, but I think it's distinct from surface water markets in a couple key dimensions. It doesn't rely on infrastructure, right? When we think about the state of California and the ability to trade surface water, you think, how can we actually move it around physically, right? But for groundwater, we're talking about a system where we all have allocations, and I'm perhaps paying my neighbor not to pump so I can pump more. And it's this agreement that keeps us all within the cap on the basin, but we're not physically moving water around. So it doesn't rely on infrastructure, unlike surface water. Think of it as being isolated to local interconnected groundwater basins, right? So we're not going to be trading across the state where you're in a totally different, disconnected hydrologic region. And key to this, right, it requires setting a cap on the total amount of pumping that is sustainable in this local interconnected groundwater basin, and setting, individual entitlements for how much a person could pump within that year. So the allocations we're talking about under SGMA. So allocations and a cap, which would be like the sum of all the individual allocations within a basin, are precursors to any kind of groundwater market system. And so this is really for the case where these basins under SGMA in the state where they can't meet their sustainability targets with supply-side strategies alone. We're really talking about the regions where demand management is necessary. That's where questions about the potential for groundwater markets are relevant. So there's a really large literature across both economics and engineering that talks about the potential gains from groundwater trading using a variety of different methods. And this is a graphic from a meta-analysis that I'm working on right now that is highlighting all the different studies that estimate the gains from water trading around the world. And you can see there's tons of studies, many of which are in California, some of which are specific to groundwater in California, and across the board they're showing, large and positive gains from water trading. But there are several challenges with actually trying to realize those gains and implementing these markets in practice. So this is coming from a summary kind of perspective piece written with Katrina Gesso for Nature Climate Change, where we thought through some of the challenges that are specific to groundwater markets that need to be reflected in kind of the design and implementation of these markets. One, monitoring and metering. Agricultural groundwater is rarely measured, but of course this is going to be really key to any kind of allocation and trading scheme. The second is the assignment of property rights, or essentially how do you determine these individual allocations that kind of set how much someone could potentially trade. And while the way those allocations are determined doesn't influence the kind of headline economic gains that are available in the basin, they're still pretty contentious or can be in terms of how they're allocated, and they can create different distributional impacts. So setting those allocations can be both really challenging and really important, kind of irrespective of the gains from trade. Third, an interesting feature of groundwater is that there are differences spatially in where this groundwater is pumped. And so kind of some of the potential impacts of pumping can differ spatially. For example, if one pumper is located close to a stream, whereas another one isn't. And so the ideal groundwater market system would kind of account for these different external impacts and how they vary spatially, which is, of course, very challenging to do. And then finally, determining the geographic domain, I think, is another challenge, because there's kind of trade-offs with you want the market to be liquid and there be potential buyers and sellers so that people can make these mutually beneficial trades, but you don't want to extend beyond kind of what is hydrologically connected, because you might introduce other challenges from that. And so there's this little bit of a geographic trade-off there. So those are some of the things we kind of discussed in this paper. But of course, now, since then, there's been more development under SGMA and kind of more challenges that have come out. So here I just wanted to show, now that we're several years in, we've had these 5-year updates of the GSPs that have been submitted to DWR. And so we were able to look through those 5-year updates to try to get a status update on what groundwater markets were developing in California. And so here is kind of a map of those regions on the left-hand side. So you can see most of this, the action for groundwater market development is in the southern half of the Central Valley, not surprisingly, because that's where so many of the basins are most critically overdrafted and are most likely to have to do some kind of demand management in order to achieve sustainability. The regions in yellow are regions that are progressing in determining allocations. and the ones in blue have established allocations and have done some progress toward water market development. But it's been, just from this look at the 5-year plans, which of course I'm missing so much of the kind of local knowledge of what's happening. I'm only gleaning this from these 5-year plans, right? But just from that, you can tell that there are challenges with implementing these markets. McMullen GSA has stalled in trying to coordinate the allocations and are kind of stuck at this stage, even though they express interest in developing water markets. Madera County conducted a groundwater market simulation, kind of pilot project, and then after that deemed it too challenging to try to implement at a bigger scale. West Side allows trading, but there's no kind of formal market mechanism. The Fox Canyon market, which for a while was kind of held up as the poster child of groundwater markets under SGMA, went to a court adjudication process. It sounds like there's maybe a third party there that is proceeding with developing a market independent of the GSA, from what I can tell, but clearly there have been some challenges with their market. Mid-Cahuilla is in the process of doing a water market pilot and so far seems to be moving forward. And then from what I can tell, Eastern Tule and Lower Tule, trading is allowed, but at least it's unclear from the 5-year plans if or how much is happening and what some of those details are. So, you know, again, with the caveat that there's so much local knowledge that's missed from just gleaning these 5-year plans, I do think it kind of gives a high-level kind of statewide snapshot of the groundwater market development, and I think highlights just how challenging it is to actually do these in practice. And we can have tons of academic studies that show there are gains from trade, and I think all of that is true and good, but actually doing it on the ground can be really, really hard. So in May 2022, the California Water Commission put out a report discussing groundwater trading and some of the kind of safeguards that are needed in place. And that was kind of commissioned through Newsom's water resilience portfolio, and it involved a ton of outreach to people throughout the state with different experience, culminated in this big report. And it highlights, I think, a whole nother set of potential concerns with groundwater markets. One, it kind of highlights these perceptions that markets would only benefit those who buy water, and those who sell their water are like perceived as losers. Those are my words, but that's my interpretation from the report. And it also highlights other fears about market power and fears about the loss of small-scale farming if kind of the big guys buy water and the small farmers sell their rights and exit farming entirely, leading to a lot of, potentially changes to the local community. So kind of as like the next strand of research, I wanted to try to investigate some of these concerns using a groundwater market that has been trading for several decades to kind of shed light. Are some of these dynamics, did they happen kind of in this one basin where we have trading data? So before diving into that, I just wanted to point out that I think there is an inherent trade-off here between the potential gains from trade and these fears about consolidation that might lead to the loss of small-scale farms or the potential for market power that were highlighted in this report. So we know that water markets have the potential to generate these large efficiency gains relative to policies that are like an allocation that doesn't allow trading. That's what I'm kind of referring to as these more prescriptive policies. But at the same time, consolidation could result as, it's like one of the key ways in which those gains from trading might be achieved is because the high productivity firms would buy rights from the low productivity firms. And if that's, if the low productivity firms are the small farmers, then that could lead to a loss of small scale farming. Because, for example, if you think of just economies of scale, then the big guys being more kind of productive as a result of economies of scale. And so some of that consolidation might reflect increased resource use efficiency that gives us these gains from trade, but at the same time, too much consolidation could be undesirable because it could potentially lead to market power or the loss of small-scale farming. And so I think there is kind of a trade-off here between different goals that you might have for a region. So we turn to the Mojave Desert, which is the west's most liquid groundwater market in Southern California in San Bernardino County. And it's an adjudicated basin. It adjudicated in the mid-1990s and allocated permits among all the pumpers in the region. And so we have 25 years of annual transaction level price and quantity data from this region that we can use to study some of these consolidation dynamics and their potential. And I'll get into some more of the details of that. So yeah, we're going to ask, to what extent does the consolidation of permits occur due to trade, and what are those implications with respect to market power, the loss of small-scale farms? So with this transaction data, we have both the permanent rights and as well as temporary lease data. So using those permanent rights data, we're going to track the consolidation by individual owners over time by measuring the ownership share of those rights held by the top 10%. And then we'll decompose those trends to understand movement of owners in and out of the top 10%. We're going to use the temporary lease data to empirically test for market power. And then we'll evaluate the composition and compensation of those who sell out and exit the market entirely. So here's an aerial snapshot of the region that I think just highlights how if there were not groundwater pumping, there would not be, it's the desert, right? So there was persistent overdraft from the mid-1940s onward, and that led to the adjudication and this tradable rights system that was established in 1994, where it established what the safe yield was, an annual ramp down because the permits were initially grandfathered in based on historical use that was unsustainable. So a path to ramp down to the safe yield. And there was a water master assigned who would oversee and approve all the trades that happened in the basin. And there's a lot of different type of users in this region. There are agricultural users, there are public water suppliers supplying water to a handful of cities in the Mojave Desert, solar developers, recreational lake operators, and there are brokers in this market as well. And in this data, we're able to kind of just observe the name of the different traders. So we're kind of deducing kind of which sector they belong to based on the name that we observe in the data. Those initial rights were grandfathered in based on the amount volumetrically used in each of the 5 years preceding the adjudication. And so an individual pumper got the maximum amount they used in any of those 5 years. So we were thinking this was more favorable actually to farmers than the public water suppliers because they typically face more variability from year to year. So just a quick note on the initial allocation of permits and kind of questions related to equity or the distribution of those permits that are irrespective of any trade, is that from the beginning, from this policy that grandfathered the rights in based on historical use, it led to the top 10% of owners controlling over 65% of those water rights. And the top 1% controlling 25% of those rights. And so, I leave it to you guys to think about, whether or not you think that is equal or unequal distribution, but that's kind of irrespective of trade, just based on grandfathering in the permits. And then, I didn't mention there are 5 different subregions within the Mojave Basin, and they all operate essentially as separate markets because you're not allowed to trade water across these subregions. And they were each ramped down slightly differently over time in order to achieve sustainability, and this is what that ramp down schedule looks like. Yeah, so here are the different regions. The greatest amount of trading is happening in the Alta region where the town of Victorville resides. So previous research led by my co-author Andrew Ayers has already kind of studied this market and shown that with the establishment of these allocations and trading regime, the groundwater resource itself improved dramatically, recovering groundwater levels in the region. And he also modeled the gains from trade and found really large positive economic impacts from establishing these property rights for groundwater and managing the system. So that's all great. We're kind of trying to push this forward by asking some of these other questions around kind of the trends in the market in terms of consolidation of permits, understanding who's buying water, who's selling out, and kind of getting another look at how this market is functioning to shed light on some of these potential concerns that folks have with groundwater market development under SGMA. So, like I said, we're tracking the consolidation of rights held by the top 10%. And so, paralleling kind of our knowledge of like the wealth inequality literature when we think about the wealth held by the top 10%, it's kind of a parallel with thinking about water wealth in this setting. So what we found, remember, from the initial point in 1994 when these rights were established, the top 10% held 65% of the rights. And what we see that over time, that grew gradually till, and the share grew from 65% to about 75%. So, our interpretation of this is that, consolidation increased, but not dramatically over time. And then we can, again, borrowing from the wealth inequality literature, we do a decomposition of this top 10% ownership share. So the same line I showed you before is graphed here in black. So that's the total kind of cumulative change held by the top 10%, showing that 15% increase. And then it's decomposed into a number of different terms. And all I'm going to do is point out here the kind of blue within term that's declining over time. And what that tells us is that this isn't really a story of like the rich getting richer in the Mojave Basin, because it's not those from the beginning that continue to acquire water wealth by purchasing more water, and that this increase over time is being driven by other compositional changes of who is entering into the top 10%. So now transitioning to look at who is kind of selling out of the market. What we saw is kind of in the first half of our sample, there were kind of new entrants to the market. There were firms exiting and new entrants entering that kind of held the total number of market participants constant for a while before that began to decline. Roughly half of the original owners had sold out and exited entirely after 25 years. And these sellouts tend to be non-municipal users from what we can tell in the data. We also looked at their ownership holdings, and so we can see that those who are selling out and exiting the market are smaller on average, holding on average 40% less water rights. They're more commonly agricultural water users, and so that combination is suggesting that from what we can observe in the transaction data, that sellouts are on average smaller agricultural users, although the prices they receive from selling out seem to be equal to those received by other market participants. Who's buying? A lot of the top ownership shares are held by the large public water suppliers in the region. So there's been these growing urban centers in the Mojave Basin, and public water suppliers have been needing to acquire more water to support these growing populations. And so the share of rights held by public water suppliers has increased over time. And so in order to investigate these questions about market power, we want to ask, can large municipal buyers influence the price over these small farmers that are, on average, the ones selling and exiting the market? So these next two slides are really only appropriate for the handful of economists in the room, but we derive markdowns and express them as a function of the inverse elasticity of supply in the form of a Lerner index, and then empirically estimate the elasticity of supply, instrumenting for water use with the ramp down policy that we're going to assume is an exogenous shock to supply. And so here are some regression results that I won't bore you all with, but the point of it is that we don't find meaningful markdowns here based on the elasticity of supply that we're estimating, suggesting that this is a relatively competitive marketplace. We're not seeing much potential for market power. Okay, so taking all this together, of course, like Mojave has its unique features in terms of, you know, the nature of the economy there, the type of agriculture that's grown there, the fact that cities have developed and there's been a lot of demand for urban water supply. And a lot of those features aren't necessarily going to apply to other regions under Sigma where just the you know, those institutional and physical features are just different, right? But I still think there are, you know, it's still good to be looking towards the places that have been doing this groundwater trading in the past to see what we can learn from them, so that we can go into this Sigma groundwater market development, you know, as informed as possible. So the handful of lessons I think that we learned from Mojave is one, I mean, the initial allocation was unequal from the start based on this, you know, the grandfathering in based on historical use, irrespective of trade. We saw mild consolidation occur over 25 years where that top ownership share increased by 10 percentage points. We did not find much evidence of anti-competitive behavior by evaluating the transaction data. And we saw that about half of the original owners sold out, largely agricultural users on average, but they appeared to be fairly compensated. So just to wrap up, I think, of course, Sigma has a lot of potential to improve groundwater resources in California. It can come with, you know, short-term costs for the places that have to do demand management, but that there are specific policy choices that can affect the degree of, you know, that kind of economic cost. And you know, allowing trade of allocations is one of those that can have an impact on kind of the economic implications of demand management. And there's, you know, there's a large literature in economics that suggests, you know, significant gains from allowing trade of these allocations, but there are, of course, a ton of challenges with implementation in practice. So I hope this kind of shed light on that a little bit, and I look forward to any questions and discussion. Thank you.
Thank you, Ellen. We've got a question here.
Hi, my name is Sophie Mulholland, and I'm a consultant on water. I have been actively involved with the water marketing in Fox, as also the Mid-Kauai, also the Greater Kauai, which you did not mention, and the Lower Tule. And a couple of observations have been on the ground. That Lower Tule, for example, has been disbanded, and they're forming a new one. And part of that I'm finding in all the GSAs that I'm involved with is that there's a lot of competition, and depending on who makes up the board, the rules change. And in terms of trading, in the Fox Canyon, that worked out really well. I am on a board of one of the major players in that, and I can tell you that it has cost an enormous sum in litigation fees that the smaller farmers could not afford, and they did get left out. In terms of the Mid-Kauai, we're going through some really interesting ways to operate the system that you have to sort of figure out. So like you have an area, it's in the same area, but it's having problems with subsidence. Mm-hmm. So they aren't allowed to pump. Mm-hmm. So right down the street, where they can pump, they sell their water rights, which they can't pump anyway, to somebody else. So the question is, if we're trying to limit the amount of water that we're taking out of the ground, a lot of these are little ways that we get around it. And so it's very, very, very complicated. And I hear what you're saying, that it's a good alternative. But I mean, I can name 5 other things that I'm seeing happen with the setting up of these trading units.
Yeah, thank you so much for that.
Hi, Ellen. Thanks. That was really good. So I guess one of the things it looks like you were saying in part of the Mojave experience was some of the trading was basically, a lot of the trading, it sounded like, was going from agriculture to urban in that sense. And so I'm wondering, what happened to the ag economies in those areas? And have people been looking at markets that would have restrictions, not necessarily, you can't do any ag to urban trade, but some kind of restrictions that preserve more agricultural lands?
Yeah, that's a good question. I haven't seen anything of that, of restricting ag-urban trade. Maybe Sophie has seen in her experience, so I'm not totally sure. We haven't also tracked other data like about the agricultural economy in the Mojave, but we could look at other indicators, and I'm sure you would see those trends show up in other indicators. Yeah.
So thank you. Very interesting presentation, and I have maybe one observation, two questions that are quite different. The observation about the small agricultural sales, I'm just wondering if you got into it, if it's just part of the transition of what's happening with small farming, that people are getting out of the business. Maybe they're selling their land for development and so forth. So it'd be really interesting just to see. That's just an observation. I may have missed it, Ellen, and I apologize if I did, but what is the end goal of the Mojave water market? What is the main reason? Is it to cut down on groundwater use? And if so, is that reflected in the ramp down? I'm not sure I kind of totally got that. And then my other question I'll follow up with is very different.
Okay. Yeah. I mean, my understanding is when they adjudicated in the mid-1990s, there was a recognition that they needed to, halt the continued overdraft, and so they made a plan to, assign the property rights on the basin and determine that safe yield and ramp down in order to achieve the safe yield. My understanding, the trading, of course, you can do all of that without trading, right? That's just a matter of setting allocations. My understanding is that the trading was part of the buy-in and how they got everyone to agree to it. But I'm sure it's way more complicated than that.
Yeah, no, that's helpful. I just didn't know if I missed it. The other question has to do with the California Water Commission and the report in 2022. Now, they also had a follow-up to that where they were interviewing people from other states, including myself. And they put out a report, was it a year ago that they had, or a year ago in the fall? I mean, because I know it wasn't as long ago. Have you followed that, and what did they find? Or am I just going nuts and 3 years went by so quickly that I can't remember?
I mean, I might have missed it. I think with this report, there were 2 stages where it was like in a draft. They did a couple stages of outreach. There was a draft format, and then it was finalized. Maybe there was something else, too, that I missed.
Does anybody know? It might have been the finalization of it or something, because I
Yeah.
know they had a public meeting. I got invited, on Zoom,
Yeah.
but I couldn't attend, so.
Yeah.
Okay.
Yeah.
Thank you so much for this presentation. I will echo what Doug just mentioned, is that if you will put water on the open market, I can see it if it is not well regulated, just to protect the farmers. There is a big risk that water, it will go for urban sector, and most of the water which is allocated for agriculture is probably will end up by being irrigating golf courses, because those golf courses, as an example, they are the one which they provide you a high value for each unit of water which is provided. So I think water trading on groundwater or on water in general, if it is not separated by categories, it might be a big risk for the growers. So this is just like a comment. Based on your analysis, I see that you have done a meta-analysis on research. Is there any place in the world, I don't know, in Spain or in Australia, where it was a successful story about using groundwater for water trading? I know there is a lot of good stories about water trading on surface water, but on groundwater, is there any place that we can learn, from around the world that we can trying to learn from their experience and apply it here in California?
Yeah. Of the studies that kind of quantify the economic gains from water trading, there's a huge focus on surface water relative to groundwater. Maybe 10% of the studies that exist focus on groundwater, but and I can't tell you exactly which countries they were modeling, but there's a mix, right? A lot of that work is modeled, and it's not necessarily based on using historical transaction data. I think those types of studies are actually quite rare, and this Mojave Basin one is one of the few that we have evidence of for groundwater specifically based on historical transactions. So I don't have one off the top of my head, but I think it's that kind of empirical evidence in other places for groundwater specific is pretty rare.
Any other questions for Ellen? All right, thank you so much. Let's give her a hand.